Now we are going to start the lecture 3 of chapter 2 class 9th polynomials. So in this lecture we are going to talk about remainder theorem. So we are saying let Px be a polynomial whose degree is more than 1 or more than 1, and there is another polynomial we are saying x minus alpha. So degree of x minus alpha is 1, and we are dividing px with x minus alpha. We are saying this thing that it is px and we are dividing it with x minus alpha. Suppose we are saying the quotient that we have over here, whatever the polynomials are there, the coefficient is qx and the remainder is rx. Now from the division algorithm we have this thing. We can say that px is equal to x minus alpha into qx plus rx, and the second condition we get is that degree of rx is less than degree of x minus alpha. Degree of x minus alpha is 1. It means degree of rx is less than 1. It means degree of rx is equal to 0. So degree of rx is 0. What this thing means? When we are saying degree of rx is 0, it means rx is a constant. The polynomial of degree 0 is a constant. It means rx is just a number r. So our division algorithm comes in this form, that px equal to x minus alpha into qx plus some number r. It means if we are dividing any polynomial with a linear polynomial x minus alpha, then the remainder will be a number. This is just a number. Up to this we are just saying this thing, that if we divide any polynomial with x minus alpha, the remainder will be just a number. So if we put x is equal to alpha on both sides of this equation, what we get is p of alpha is equal to alpha minus alpha to q of alpha plus r. Alpha minus alpha is 0, so this whole term will become 0. So what we get is p of alpha is equal to r. That is the remainder left. R is the remainder. So we are saying when we divide any polynomial px with x minus alpha, then we need not to, and we want to find the remainder. We want to find the remainder. We need not to manually divide that polynomial. We can just find the value of p of alpha and that will be the remainder. This thing will be more clear to you with an example that we will see in our next slide. So our question is, find the remainder when this polynomial is divided by x minus 2. So one procedure is that you write x raised to the power 4 plus 2x cube minus 3x square plus x minus 1, and you divide it with x minus 2. You make this calculation and find the remainder. But from the remainder theorem we know that this remainder is equal to p of alpha. Now what is alpha over here? We are saying we are dividing with x minus alpha. We are dividing with x minus 2. So what is the value of alpha over here? It is 2. It means the remainder will be equal to p of 2. So what is the value of p of 2 over here? It is 2 square plus 3 into 2 cube minus 3 into 2 square plus 2 minus 1. We just substitute x is equal to 2, and when you solve this value you will get the answer is 21. So we need not to do the division. We can directly tell what is the remainder in these kind of divisions. Similarly, The next question is find the remainder when the polynomial is divided by x plus 3. Now it is x plus 3, we have to compare it with x minus alpha. So x minus 3 means I can write it like x minus of minus 3. So value of alpha is minus 3. This is important over here. We are comparing it with x minus alpha. So we are writing first it as x minus minus of 3. So the value of alpha you are getting, it is not 3 but it is minus of 3. And the remainder, for the remainder, what we have to do is we have just to calculate the value of p of minus 3, that in place of x we will substitute minus 3, and the answer we will get it is minus 3 cube minus 3 into minus 3 square plus 4 into minus 3 plus 50. So minus 3 cube means it is cube over here and minus sign is there, it is minus 3 cube. It is minus 3 square. So this minus 3 square will become plus 3 square. Minus sign is already here. So it is minus 3 cube. Then it is minus 12 plus 50. So the answer is minus 16. Again, we need not to make the complete division or perform the complete division. We will find the value of alpha. You find the value of p of alpha. You put that value, and whatever the answer we get, that is basically the remainder. This is what remainder theorem is saying. That is where the remainder theorem is used. We are saying we need not to make the complete division. To find the remainder, we can directly calculate the value of p of alpha. Similarly, in this question, we have gx is equal to 2x minus 1. So what we are saying over here, what we require is, we require x minus alpha. Our remainder theorem was when the number is in the form of x minus alpha. So we are saying what we do, we substitute, we find the value of p of alpha. So how we are getting this value? Basically we are equating this term equal to 0, and we are saying what we are doing is we are substituting x is equal to alpha and we are substituting this value over here. So in this particular case, what we are going to do, it is gx is equal to 2x minus 1. So we equate it equal to 0. When you equate it equal to 0, you will get x is equal to 1 by 2. So alpha in this case is 1 by 2. So this is more convenient way to find the value of alpha, that whatever the value of gx is given to you, you equate it equal to 0, because this is a linear polynomial and the remainder theorem is valid for all the linear polynomials. So we are saying it is 2x minus 1, this is equal to 0, equate it equal to 0, you get the value of x is 1 by 2, it means alpha we have to put it is 1 by 2. When you substitute these values in this equation, it is 1 by 2 cube, 1 by 2 square and 1 by 2. On solving this, you will get it is 3 by 2. It means when you will divide this polynomial by this polynomial, the remainder will be 3 by 2. Similar is the next question. You have to find the remainder when this polynomial is divided by gx is equal to 2 plus 3x. Now you know how to find the value of alpha. You just write 2 plus 3x, equate it equal to 0. You get it is 3x is equal to minus 2. This implies x is equal to minus 2 by 3. What we have to do to find the remainder, we have to calculate the value of p of minus 2 by 3. So when you will find p of minus 2 by 3, it means in place of x you are writing minus 2 by 3. It is x cube over here. So we have substituted minus 2 by 3 whole cube. It is x square over here. So we are getting minus 2 by 3 whole square. Next is x over here. So it is minus 2 by 3. And when you will solve these values, you will get the answer is 1. You can try to solve this value and you get the answer is 1. So it means whenever you divide these two polynomials, the remainder will be 1. You can check this by manually dividing these two polynomials and you will come to know that the answer is 1. Now the next is find the remainder when this polynomial x cube plus 3x square plus 3x plus 1 is divided by x minus pi. So the same procedure is there. You equate this is equal to 0. You get x is equal to minus of pi. You put x is equal to minus of pi in this equation. You get minus pi cube plus 3 into pi square plus 3 pi plus 1. So answer is minus pi cube plus 3 pi minus 3 pi plus 1. So this is the answer you are getting over here, that it is minus of remainder that you will get after dividing this with pi plus x plus pi is minus pi cube plus 3 pi square minus 3 pi plus 1. You need not to divide manually, you just substitute or you just put this expression equal to 0, find the value of x, whatever value of x you get, put that value of x in the given polynomial and you will get the remainder. This polynomial px and gx are given to us and we have to check whether px is a multiple of gx or not. Now what this question means, if suppose I am asking you that a number 9 and 3 is given to you, you have to check whether 9 is a multiple of 3 or not. So what we are basically saying, we are dividing 9 with 3 and if we find the remainder it is 0. If the remainder is 0, we say 9 is a multiple of 3. Similarly, if we have to check whether px is a multiple of gx, it means we have to divide these two polynomials and if the remainder is 0, it means that px is a multiple of gx. So what we have to do is we have to find the remainder and we know how to find the remainder is we equate this equal to 0. So we get 2 minus 3x equal to 0. We get 2 is equal to 3x. This gives us x is equal to 2 by 3. We substitute this value of x in the given equation and what we get is 2 by 3 cube then minus 2 by 3. And when you solve this value, you will get the answer is 17 by 27 and which is not equal to 0. So we are saying px is not a multiple of gx. If this remainder is 0, then we will say that px is a multiple of gx. Now in the previous question, we were checking whether it is a multiple of px is a multiple of gx or not. Another way of saying this is that gx is a factor of px. We are saying 9 is a multiple of 3 or we can say 3 is a factor of 9. So both these things, these are same. So we have to check whether 7 plus 3x is a factor of 3x cube plus 7x. So to do this, what we have to do, basically what we are saying that 3x square plus 7x is a multiple of 7 plus 3x. To solve this, we will equate this equal to 0. So we will get x is equal to minus 7 by 3. We will put x is equal to minus 7 by 3 in this equation. So what we will get is, it is 3 into minus 7 by 3 cube plus 7 into minus 7 by 3. And you will solve this value, minus 7 by 3 cube, it is minus 343 by 27 and minus 7 by 3 is there. So when you solve this, it is minus 49 by 3. On solving this, you will get it is minus 490 by 9. Again, it is not equal to 0. it means the remainder is non-zero. So this 7x plus 3 is not a factor of 3x cube plus 7x. Now we are given two polynomials in this question, and another polynomial is given, and the condition that is given to us is when we divide the first two polynomials, when we divide this polynomial and this polynomial with x minus 2, the remainder we have, it is same. Both of these divisions is the same remainder. So what we have to do, we have to calculate the remainder in both these cases. We know how we calculate the remainder. We equate it equal to 0. We get the value of x is equal to 2. We substitute x is equal to 2 in both these equations. When we substitute x is equal to 2 in the first equation, we are getting it is 2 into 2 cube plus a into 2 square plus 3 into 2. When we are substituting it in the second equation, we are getting 2 cube plus 2 square minus 2 into 2, and on solving this we are getting two expressions, 17 plus 4a, and second expression is 8 plus a. Now what is given to us is that both of these values, these are same. So if both these values, these are same, it means 17 plus 4a, that is equal to 8 plus a, and on solving this equation you will get it is 4a minus a is equal to 8 minus 17. So 3a is equal to minus 9. So a is equal to minus 3. So if the value of a is minus 3, then both of these will leave the same remainder on dividing with x minus 2. And we have to find the remainder also, and the remainder will be, you can say it is 17 plus 4a, you can substitute the value in this, or you can substitute the value in 8 plus a, that is equal to 8 minus 3 is equal to 5. So 5 is the remainder in both these cases.